All right, good morning, good morning, good morning. We will start in about a minute. Starting in about a minute. All right, good morning, guys. Hopefully that homework went okay. Did that stimulate some of your memories from last year doing this in pre-algebra, graphing inequalities? All right, just so you know, nearly the entire chapter, we're going to be using that skill, how to graph inequalities, for our answers. Today's a pretty easy day. I'm going to teach you something that I taught you last year, but it took us 4 days. I'm going to do it in 2 days. Okay. So remember, it's a Friday, so I'm just collecting homework. Make sure you plug in everything on Teams. It's another worksheet. It's solving inequalities, some basic ones. And then we have to add one extra step when we solve these inequalities, and that is we have to graph the answers. But we'll do plenty of examples here. Should bring back some memories from last year as well, too. We'll get to the new stuff next week. And then enjoy your time reviewing the stuff, because the new stuff is pretty challenging. All right, here we go. Solving inequalities, solving inequalities. 4 basic things. We're going to talk about what changes when we solve inequalities as compared to solving equations. Just one basic thing that changes. However, the answer must be written in graph form. All right. So some quick explorations. Let's see. I think we'd all agree that 6 does equal 6. Are we allowed to subtract anything from both sides? We did this before. We find out that yes, you are allowed to subtract anything from both sides of an equation as long as it's the same number. If I subtract 3 from one side and 2 from the other side, we wind up with an inequality. So we say that for an equation, you are allowed to subtract. The equality is maintained. Now notice 4 is not the same as 6. But if we start with a true equation, 6 equals 6, we subtract the same thing from both sides, we wind up with another true equation. Okay. Does this work for inequalities? Well, let's see. Let's subtract the same thing from both sides. We do get a different inequality, but notice we get another true inequality. So you are allowed for both equations and inequalities to subtract the same thing from both sides. Now, be careful. We're saying it must be the same thing. So we say the inequality is maintained this time. So you are allowed to subtract anything from both sides of either an equation or an inequality, and it will be maintained. Will that also work for greater than? Well, let's see. Let's subtract 2 from both sides. And yes, inequality is maintained as well, too. The main point here is that no matter what the inequality, you are allowed to subtract the same thing from both sides. Life still remains good. All right. Would that work for addition? So I'm showing here if we don't subtract the same thing from both sides. Notice if I don't subtract the same thing from both sides, we wind up with a truly false statement. 4 is not smaller than 2. Okay, so as long as you subtract the same thing from both sides, you're good to go. All right, so inequalities are not maintained if you subtract the different thing from both sides. That works for both less than or greater than. Okay, if we subtract different things, we wind up with something that's not true. 1 is not bigger than 2. So we will be solving inequalities today. So remember, this is as simple as it gets in Algebra 1, right? If we have a one-step equation to isolate the variable, in other words, to get x by itself, we subtract what's attached to the variable, in this case, plus 3. We use the inverse of adding 3s. We subtract 3 from both sides. We get to an answer. We do the exact same process with inequalities. We literally do the same thing. We just showed in the previous slide that we are allowed to add or subtract anything from both sides as long as it's the same thing. So what's attached to x? Positive 3. The inverse of adding 3 is subtract 3. We subtract 3 from both sides, and we get x is less than 2. Here's the only issue. The issue is it is an inequality. Therefore, we have to graph our answer. You remember from last night's homework, number line, 1 tick mark. The one number we will use is 2. Where did I get 2 from? It says x is less than 2. It's going to be an open circle because it's not less than or equal to. And then we got to decide whether we shade left or shade right. So the solutions are all smaller than 2. The numbers that are smaller than 2 are to the left of 2. There you go. That is what we're doing today. You're like, okay, I'm good to go. Let's start the homework. Well, there are some ones we got to talk about here. All right, so here's a couple quick examples. Variables on the left side, what's attached to it? Plus 15. It's attached by addition. You get rid of addition by subtraction. We subtract 15 from both sides. 3 minus 15, negative 12. Different signs mean subtract, big minus small. There's more negatives and positives. And then we have to graph our answer. So let's see. Tick mark with a negative 12. This time it will be a closed circle. Notice I've got a line underneath of it. Closed circle. Okay, shade left or right. Let's see. The solutions are all smaller than or equal to negative 12. The solutions that are smaller than negative 12 live to the left. So we shade left and we're done. So a little bit of extra work. I will say you're going to do this so often you can get to where you can graph your answer in 15 seconds or less because it's not that complicated. One more example. Yes, we can have some ugly numbers here as well. 1.7 is positive, so to get rid of the positive number, we subtract. 3 minus 1.7 is 1.3. We got a graph. Tick mark 1.3. Don't panic because it's a decimal number. It's still fine. This one is an open circle. Once again, it's an open circle because there's no line underneath. I read this. I always read it from variable to number, variable to number. And as I read it from left to right here, it says that D, I'm going to say the solutions. The solutions are bigger than 1.3, where the numbers that are bigger than 1.3, those will be the numbers to the right. All right, felt like I was going a little fast there. Let me pause. Any questions from anyone? By the way, we did this last year in pre-algebra. I mean, literally, I just copied these slides from the pre-algebra class. We will get to the more complicated ones starting on Tuesday. All right, here are two. Here are two in front of you. I'll give you about a 20-second head start. Remember, all your answers have to be graphed. All your answers have to be graphed. All right, the top one, it says J plus 7.4 is less than or equal to negative 3.2. The variable's on the left side. Yes.
When you're subtracting decimals or like the decimal place, then you just line them up and subtract like normal, right?
Or add, depending upon if you're adding. Yes.
Okay, thanks.
All right, so just to show you what she was saying once we decide that we need to subtract 7.2 from both 7.4 from both sides, we got a negative 3.2. And we put the other one underneath minus 7.4. We line up the decimal places. Notice the signs are the same, so that means we add the two numbers. So we get a 10 and a 0.6, and since we were adding negatives, the answer is negative 10.6. All right, but it is an inequality, so we have to graph our answers. So let's see, closed circle, shade left. J, and I don't usually say J, I say the solutions are smaller than or equal to negative 10.6. So the numbers that are smaller than negative 10.6 live to the left. It's a closed circle because of the less than or equal to symbol. And there you go. Second one, let's see. I need to subtract 77 from both sides. No decimal involved here. If I subtract 77 from both sides, I get two negatives. That means add the two numbers. That would be an 83, and it would be negative, so negative 83. Now be careful. Notice where the variable is this time. It's on the right. Usually I get those smarty pants that say, hey, to know which way you shade, you simply look at the inequality, which way it's pointing. This one points to the right, or left, sorry, points to the left, so therefore the arrow should point to the left. Well, in this one, the arrow points to the left, but remember, we read it from variable to number. So if I go from variable to number, this says the solutions are bigger than -83, and those would be to the right. I get some, I don't know, ultra smarty pants that say, well, I'll just remember if the variable is on the left, we just go in the direction of the arrow, and if the variable is on the right, it's the opposite. You know, by the time you get to Algebra 1, if you want to make those rules for yourself, I'm fine with that. That is true, by the way. But for those of you that can't remember those rules, don't get yourself into trouble. Just read it from variable to number. All right. Any questions on these easy ones? Let's do some more easy ones. All right, well, we just did solve by subtraction. Let's solve by addition. So first off, let's explore to make sure this works. You start off with an equation. You're allowed to add anything to both sides as long as it's the same thing. That's the same for both equalities and inequalities. I can add the same thing to both sides. And notice I wind up with another true statement. 8 is smaller than 12. Okay. It also works for less than, it works for greater than. Let's add 2 to both sides. We wind up with 8 is greater than 6, which is true. So you are allowed to add the same thing to both sides. You can't add different things, but you can add the same thing to both sides. All right, so add different things to both sides, bad things happen. We get 14 is smaller than 12, which is clearly not true. So make sure you always add the same thing to both sides. All right, and once again, I'm just showing you that that does not work when you add different things to both sides. 8's not bigger than 9. All right, let's solve some equations, or inequalities, sorry. So let's see, t minus 7 is greater than or equal to -3. Variables on the left side, -7 is attached, or 7 is attached to t by subtraction. We get rid of subtract 7 by adding 7 to both sides. Different signs means subtract. 7 minus 3 is +4. Graph our answer, closed circle with a 4, shade, the solutions are bigger than 4, so shade to the right. And there you go. Look at that. Easy, easy, easy. All right, yeah, let's do some one with decimals. Kaylee said that if we deal with decimals, then we need to line up your decimal places. Notice that when we add 3, there is no decimal place on the 3, so you can always put 1. Usually algebra students don't make that mistake, but a non-algebra student, let me go back, a non-algebra student might make this mistake. As soon as you decide to, come here you, as soon as you decide to add 3 to both sides, if you're not paying attention, you might put +3 right here. And therefore, because it's really 3.0, you didn't line up your decimal places. So that's more of a, I don't know, an 8th grade mistake, not a 9th grader mistake. So just be careful. So we add 3 to both sides. That gives us what, 4.1. So x is greater than 4.1. Open circle, bigger than 4.1, shade right. Open circle, shade right. Feels like I'm going kind of fast. Are we okay? No complaints. All right, here we go. Once again, I'll give you guys, I don't know, a minute head start on these two. Go ahead and do these two. Remember, you got to graph the answers, and then I'll work through each one. Pipe up if you have a question. All right, let's see. The first one, we got to add 15 to both sides. 15 and 3 is 18. So we get n is smaller than or equal to 18. That would be closed circle, shade left. All right, let's see what it would look like in real time if I were to do this. Second one, variables on the left, 6 is attached by subtraction, so we want to add 6 to both sides. Draw a line. N greater than 6 minus 4 is 2. Number line. 2 is in the middle. It's going to be an open circle. N is greater than 2, so the solutions live to the right. So there is one done in real time, and it's not too bad. Okay. Questions? Here's it nice and pretty. All right, we just did 2. Now we're going to deal with where the combination of things. So the thing that most of you guys hate are fractions. So let's do a couple with fractions. By the way, these are fractions like you will see in Algebra 2 senior year. So you can get some really ugly fractions senior year. Be ready for it. So we're not seeing any ugly fractions yet. All right. Fractions will be a little bit messy. All right. Be ready for it. We learned a technique about clearing fractions early for equations. I'm going to hold off on that idea about clearing the fractions until I teach you one more thing. So when you first start this, if you're not allowed to clear the fraction, well, then we got to make common denominators when we do this. So let's see, what's attached to t, 1 and 2/3? I always told you, whenever you have mixed numbers, always write them as improper fractions. Don't mess around with mixed numbers. So 3 times 1 is 3, plus 2 is 5, so 5/3. Now let's see, 5/3 is attached by addition, so I need to subtract 5/3 from both sides. And then what? Maybe a little bit of scratch work off to the sides, right? 1/3 minus 5/3. 1 minus 5. Look, we got common denominators. Life is good to us. 1 minus 5 is -4, so we get -4/3. That would be what we get here. So t is greater than or equal to -4/3. Now, here's the only nice thing about this is I don't care that it's a fraction, right? It's just the number that goes in the middle. So -4/3 goes in the middle. Let's see, a closed circle, and t is greater than, so the number's to the right. Okay, so the key here was that I made an improper fraction first. Oh yeah, we'll get some that don't have common denominators here in a second. It'll be a lot of scratch work, so they can't get messy. And I know some of you are screaming at me, you're like, wait, can't we clear the fraction? Well, let's wait, let's hold off on that for a second, because I've got to show you one more thing. All right, here's another example. Now we're not going to have common denominators. So f is on the right side. What's attached is 3/4 by addition. So we're going to subtract 3/4 from both sides. Oh, I got to do some scratch work. Scratch work. So it's 7 minus 3/4. Well, we need that 7 to be a fraction, so we put it over 1. So 7 minus 3/4. Common denominator, 1 and 4 would be 4. Well, 3/4 already has a 4, so I'm just messing around with this first fraction. I turn a 1 into a 4 by multiplying top and bottom by 4. So that's where I got this, what, 28/4. For those who need to see what I did there, in red, I just multiplied the top and bottom by 4 and made an equivalent fraction. 4 times 7 is 28. 4 times 1 is 4. Okay? So 28 minus 3 is 25, so we get 25/4. So I get f on the right side, and on the left side, I get 25/4 with a greater than or equal to between them. Remember, be careful, right? We're always read it from variable to number. So f is, or the solutions are smaller than 25/4, smaller than or equal to. So closed circle, 25/4. I didn't have enough space here to write the whole fraction. That's why I wrote it in this form. We said that f is smaller than 25/4, so shade left. Okay, pause in there for questions.
I'm kind of confused what you did with all the fractions.
So all I did was subtract 2 fractions. All I did was subtract 2 fractions. So all I did was subtract those 2 fractions. Notice they do not have common denominators. So you got to make common denominators, right? So the common denominator is 4. Well, what times 1 is 4 is 4. So I multiply the top and bottom by 4. 4 times 7 is 28. That's where I got the 28/4.
Okay, thank you.
Okay. All right. No, I'm not going to claim that, fractions are so easy. They make your life easy. They don't. They're complicated. All right. I want you to pick one of the ones with fractions and one of the other ones. So don't do all four, but either pick one of the top two and one of the bottom two and do that, please.
Mr. C, I'm still confused on how you would do fraction one. You said that we're subtracting, but I don't understand how you would start it.
Which one are you doing? The left one or the right one?
The left one.
The left one. What's attached to x?
-1/3.
So how do we get rid of minus 1/3?
You minus 1/3.
To get rid of minus, we minus.
Well, you add.
We add 1/3 to both sides. So we're going to add 1/3 to both sides. Well, 1/3 minus 1/3 is 0. It goes away. On the other side, let's see, 5, I'm going to write as a fraction, 5/1 plus 1/3. Okay. Common denominator?
3.
So multiply top and bottom by 3. And I'll probably have some people screaming, well, the answer is just 5 1/3. Yeah, it's a mixed number. I got you. But we're just doing a more general case here. All right, 3 times 5?
15.
So we get 15 over 3 times 1 is 3 plus 1/3. So what's 15/3 plus 1/3?
16/3.
There you go. There's your answer. Now you just need to graph that and you're done.
Okay, thank you.
All right, going over the answers. The first one, you subtract 9 from both sides. 12 minus 9 is 3. So what? Open circle, shade left. X is smaller than 3. The bottom one we just did, we got 16/3. So let's see, closed circle, X is larger. The solutions are larger than 16/3. Subtract 3 from both sides. -1 minus 3 is -4. The solutions are smaller than -4, open circle. And the last one, let's see, changing that, notice we do have common denominators here. Changing this to mixed number or improper fraction, sorry, that would be 14/3 plus 2/3 would be 16/3. And yes, I wrote the same answer here. The only difference is this one, X would be smaller than 16/3, therefore shade left. There you go. That was almost everything that we did last year, with one exception, multiplication division. So some of you have been wanting to clear the fraction. Well, clear the fraction would involve multiplication, and I held off from that because we got a big problem. Big problem, right? And here is the problem. Oh, that's a problem. Here is the problem. The problem is multiplying with inequalities or dividing, we run into problems. 2 is definitely smaller than 8. If I multiply both sides by 3, it looks like life is good. 6 is still smaller than 2. 2 times 3 is 6. 8 times 3 is 12. Looks like life is good. The problem is, right, not when you multiply or divide by a positive number. 10 divided by 5 is 2. 20 divided by 5 is 4. The problem is not when you multiply or divide by a positive number. The problem is, well, when we do this with a negative number. Check this one out. I'm going to multiply both sides by -3. 2 times -3 is -6. 8 times -3, -24. -6 is not smaller than -24, it's bigger. We just did both sides by the same number and we got a bad statement here. That is a big problem. It works for both multiplication and division. If you divide or multiply by the same number, you get bad answers. -2 is not smaller than -4. So that is the problem. And I don't know if you remember it from last year. last year I said this, and you might want to write this in your notes. The rule is this: when you're solving an inequality, if you ever multiply or divide by a negative number, not with a negative, but by a negative number, then you must flip the inequality around. I mean, literally, you take less than and you make it a greater than, right? You flip it around. If you start off with a less than or equal to, you flip it around and make it a greater than or equal to, right? You must flip the inequality if you ever multiply or divide by a negative number. Notice what I didn't say. If the number that you're multiplying or dividing into is negative, that's not what causes it to flip. What causes it to flip is when you multiply or divide by a negative number. All right. We got to see a couple of examples of that. So here are the things, right? You are absolutely allowed to divide both sides when you have an equation. You are absolutely allowed to divide both sides when you have an inequality. The only issue is that when you multiply or divide by a negative number, we have to flip the inequality. So you'll see this on all my slides here at the bottom. When multiplying or dividing by a negative number, flip the inequality. You absolutely have to keep that at the forefront of your mind when you do this. Okay, so here's our first one. N is on the left side. 15 is attached to multiplication. We get rid of a multiplication by division. So we just decided to divide both sides by 15. But what I want you to always ask yourself, and you're going to see this on every slide, this statement right here, did we just divide by a negative number? The answer is no, we divided by a positive 15, so we don't need to change any inequality. We just simply do the math. 45 divided by 15 is 3, the 15's cancel. Okay, graph your inequality. The only time you flip the inequality is when you multiply or divide by a negative number, such as this time. Notice what's attached to t, negative 3, is attached by multiplication. So we need to divide both sides by a negative 3. You just said you're dividing both sides by a negative number. So you gotta flip the inequality. Notice, I should have made it red here. Notice that the inequality starts off like this, but the answer has a flipped inequality. Why? Because you just divided both sides by a negative number. So whenever you multiply or divide by a negative number, you flip the inequality. Closed circle greater than, so shade right. Questions on the basic idea. You're still going to multiply or divide, but when you ever multiply or divide by a negative number, you're going to flip the inequality. All right, let's see that one more time. X is on the right or left side. What's attached to it? 2, attached by multiplication. To get rid of multiplication, you divide. We're dividing both sides by 2. Are we dividing by a positive or a negative number right here? Somebody. Are we dividing by a positive or negative number?
Positive.
So we do not flip the inequality, even though that when you do that division, the answer is negative. We don't flip the inequality. Notice it's still less than or equal to. The only time you flip the inequality is when you decide to multiply or divide by a negative number. Just because the answer is negative doesn't mean we flip the inequality. So we only flip the inequality when we multiply or divide by a negative number. This time it wasn't, so we didn't flip it, even though the answer was negative. That's the most common mistake. Kids will see a negative number like, oh, I got to flip the inequality. No, you flip the inequality when you multiply or divide by a negative number. All right, let's do these together. All right, let's see. First one, we need to divide both sides by 9. Did I just divide by a negative? Yes or no? Did I divide? No, we didn't. So we do not flip the inequality. The inequality stays the same. Graph. I'm doing this in real time. Closed circle. The solutions are smaller than negative 11, shade left. Second one. Ooh, look, negative 3 is attached to x by multiplication. So we're dividing by a negative. As soon as you say dividing by a negative, flip your inequality so you don't forget. Notice I just flipped the inequality around. Negative 3's cancel. Negative divided by negative is positive, so we get 9. Questions on what I just did right there? I flipped the inequality. The solutions are bigger than 9, so open circle, shade right. Okay. Last one, negative 14 is attached to t through multiplication. We get through that by division. We're dividing both sides by negative 14. Oh, I just said divide both sides by negative. So I'm going to flip the, notice before I write any numbers, I flip the inequality so I don't forget. Negative 14s cancel. Ooh, 84 by 14, I believe that's 6. Positive divided by negative is negative. We get negative 6. Open circle. T is smaller than negative 6. So the solutions are smaller than negative 6. And there you go. All right, 2 of those we flipped. 1 of those we didn't. Now, I don't want you to think that just because the answer was negative, that meant we flipped the inequality. Right? That's just a coincidence. Whether the answer is positive or negative, right? You may or may not flip the inequality. So let's see. We didn't flip the inequality on the first one, the second and the third one. We flipped the inequality. On the second one, look, the answer was positive. We still flipped the inequality. On the third one, the answer was negative, and we also flipped it. So whether you flip it or not is not dependent upon the answer. Hey, the first answer was negative. We didn't flip it. It's dependent upon whether you multiply or divide by a negative number. All right, nice and pretty here. Questions? All right, well, the last thing, obviously, the only thing we haven't done is we haven't done multiplying. So we are allowed to divide by a negative number, but remember, when we divide by a negative number, we have to flip the inequality. So we flip that inequality. Graph our answers. Okay. Remember this, when we have fractions involved, right? Whenever you divide with a fraction, you do copy dot flip. You copy the first fraction, you flip the second fraction. Okay. Copy dot flip. So we will now get some with fractions in them. All right. So notice H is on the left side. What's attached to it? 3/4. It's attached by multiplication. You get rid of multiplication by division. We're dividing both sides by a positive 3/4. Don't need to flip the inequality. But remember, as soon as you decide to divide with a fraction, you need to take the fraction that's attached to H and flip it. Right? We're copying the 3/4. We're flipping the 3/4. So what I'm multiplying both sides by is what's attached to the variable flipped. I'll do that again. 3/4 is attached to the variable H. So I need to multiply both sides by that fraction flipped. I don't multiply by 1/7 flipped. That's not attached to H. We're trying to get rid of 3/4. That's the one I need to flip. Now, I didn't multiply or divide by negative numbers, so I don't need to flip the inequality. I simply do the math. On the left side, everything cancels, and on the right side, multiply straight across. Notice there's nothing to cross reduce here. We get 4/21, and that's what you will graph. And I will pause and see if there's any question. H is bigger than 4/21s. Questions? All right, let's see that again. Notice what's attached to the variable 6/11. That is what we're going to multiply both sides by flipped. I'm going to flip 6/11. That's what I'm multiplying. I did not multiply both sides by a negative number, so I don't need to flip the inequality. On the left side, everything cancels. On the right side, anything cross-reduce? Yes, look, 2 and 6. So 2 turns into 1, 6 turns into 3, because 2 goes into 2 once, 2 goes into 6 3 times. Now we multiply straight across, and we get 11/27. Can you see that? 11/27. 1 times 11, 9 times 3. Right? If you don't cross reduce, you get a big number, 22/54. 2 times 11, 9 times 6. And then you got to reduce. Well, it reduces to 11/27. So my point here is that if you can, it is far easier to cross reduce than to reduce a really big number. So I always cross reduce. Are you required to do it? No. Notice we got the same answer, 11/27. whether you cross reduce or not. Usually this one isn't too convincing of people because it's small numbers, but as soon as it turns into hundreds, the power of cross reduction becomes vividly clear. All right, we have 3 problems left and we're done for the day. 3 problems left. The first one is the scary one, right? Because you're like, isn't it done? Well, no, it doesn't say n, it says negative n. So really what's attached to it is a -1. We get rid of -1 by dividing by -1. Oh, I just said divide by a negative. So we got to flip the inequality. The -1's cancel. 14 divided by -1 is -14. Okay, so this one I flipped the inequality. I flipped the inequality, not because the answer is negative, but because I, in this case, divided by -1. Closed circle. The solutions are bigger than -14, so shade right. How are we doing on time here? Oh, we're out of time, just on time. All right, let's finish this up and then we'll call it a weekend here. All right, second one, 4/5 is attached, so I want to multiply both sides by that number flipped by 5/4 times 5/4. -16 would be over 1. Look, I can cross cancel. 4 goes into 4 once, 4 goes into -16 -4 times. I didn't multiply by a negative number, so even though the answer is going to be cancel, even though the answer is going to be negative, 5 times -4 is -20. The answer is negative, but I didn't have to flip the inequality. So -20 in the middle, open circle. X, or the solutions, are smaller than -20, so we're shading to the left. The last one real quick, we got to multiply both sides by -7/5. So we are multiplying both sides by a negative number. So step 1, flip that inequality before you forget. All right, nice thing is that all cancel. Anything cross reduce here? Nothing. Okay, so t's on the left side and on the right side, 2 times -7, -14, and 3 times 5 is 15, so I get -14/15. I already flipped that inequality, I don't need to worry about it. So -14/15. Is it open or closed circle? It is an open circle, and t is smaller, so shade left. And we're done. We are done. All right, we don't have school on Monday. I will post this video within, I don't know, 10 minutes of this. If you are doing your homework and you've completely forgotten everything, play the video while you're doing your homework. Find the one in the video that's like the one that you're doing, and that will at least give you a solid opportunity to get these done. Oh, here are the pretty answers. Okay. All right, any questions? All right, well, that does it for today. You guys have a good weekend, and I will see you on Tuesday. Oh, by the way, if there's anyone who forgot to take their test, today was the end of the quarter. So if that test hasn't been turned in, you get a 0. Make sure your tests are turned in. I did grade a whole bunch of them yesterday, but I still had a couple people. Caden was one of the ones that I did not, at least as of this morning, hadn't taken the test. Make sure you take your test. Otherwise, you're getting a big fat 0. All right, on that unhappy note, have a good weekend. Be ready to shovel some snow this weekend, but I'll see you guys on Tuesday.